Do you struggle to apply the perspective videos that you watch to the actual scenes that you then go to draw? Do you watch how to understand 1, 2 and 3 point perspective videos and think you understand them? But when you go to draw, you find you often still have no real idea how they apply in your drawing to your scene. The good news is this problem is not you. It's the videos. It's not what they tell you, which you do understand, but it's what they don't tell you. This street in a Scottish village is a great example why so many perspective videos fail to teach perspective well, or at least adequately enough that when you go to draw, you can apply what you've learned. So we're going to look at this street and explain the perspective issues it raises and why the perspective teaching videos you've watched have probably failed to prepare you for it. But first, let's look at the 1 point perspective video. But first, since this scene will probably remind you of a 1 point perspective video presentation you've seen, let's have a look at what those videos show and then seek to apply it to our street here. So we probably saw something like this. Two boxes facing each other with a space between which represented a street in all likelihood. And we saw how the perspective angles went from the corners of our buildings down to the one vanishing point on our line, which was either called our eye level line or our horizon line. And there may even have been some additional lines going towards the vanishing point from our corners with some pseudo windows put in just to make our boxes look a little more like a pseudo streetscape. And we look at that and we think, yes, I see this, this makes sense. This is both what I expect to see and what I draw when I'm looking up a street. But is this what we see when we look up a street? And if not, why not? So let's go back to our Scottish village. And here's our street. Now the first thing we do is to find eye level. So how do we find eye level? Well, the videos usually either just draw it in or have it already there. They never talk about finding it, but there's lots of people here and gosh, their eyes are all about the same. So let's say eye level is here. Now we know that all the angles of all the buildings will meet at the 1 point on eye level. So let's put a few lines down and see where they meet. And so I'm going to use this line here, and then I'm going to use this one. The perspective angles meet right over here. But hang on, if I go back to my diagram, they're all meant to meet at the same spot when you look up the street. But I can see that these ones are going to have a real problem meeting over here because they go off in this direction. Not only do they not meet over here, but they meet actually higher. And in fact, now that I look at these more carefully, they don't really meet on this line anyway. They're meeting higher as well. So what is the problem? Why don't they look like this? Well, this first complication is quickly cleared up. And the problem is that most perspective videos either start with an eye level already drawn, or it's just drawn without any explanation as to how or why it gets there. And the very simple truth is, eye level is called eye level because it's the level of the eyes of the person looking at the scene. Or in the case of a photo, it's the level of the camera in the scene. So it's got nothing to do with the eyes of our people. And if we look actually more carefully anyway, we can see that some of the people are up here, which is nowhere near the people down here. So we have to disregard where people are. Sometimes eye level happens to be the same level as the eyes of the people. And that will happen if our ground is perfectly flat and we're standing on that same flat level. In that case, the eyes of an average person looking at the scene and the eyes of an average person in the scene will be at the same height. So how do we find eye level when we have a scene already here. If we remember back to the fact that all of these angles actually meet on the vanishing point, well, that is going to be true regardless of what happens in our scene. So let's look at two fairly definite lines. We'll look at this one here, and we'll look at this one here, and we'll just try and be as accurate as we can. Now, where do they meet? So they're meeting about here. Now, that's from the left side of the street. If we look at the right-hand side of the street, we can put this one here. I'm going to take the top of these windows and doors, which I think are at the same level, and that gives us a line here. Let's just look at this one again. And so we get here and here, which is going to be a point, I think, about here. So if we just remove all these lines and look at this, this is approximately where eye level is. But my first question is, why do the perspective angles from the left side of the street and from the right side of the street not meet in the same spot? And the answer is very simple. It just wasn't told to you in your perspective video. Let's have another look at this side of the street. So here we have the first building. But with this second building, I want to grab it by this corner and just swing it towards us a little bit. How's that going to change what we see here? So now when you compare this with this, does this look like I've grabbed this corner and just pulled just this second building towards us a bit? But what has this done to our vanishing points? What it's done is that it slid the vanishing point for this second building further along. Because this is only true if all of these buildings are in a straight 180-degree straight line. And as soon as one of them is swung towards us, the vanishing point just for that building slides along. And of course, the same is true on this side of the road. Again, let's slide this building towards us. We'll grab it here and we'll pull it towards us. And again. And we see that when we do this, for this building, which is now no longer in a 180-degree angle, the vanishing point has slid again, but this time to the left. And the pattern to remember is that the more we swivel one of these buildings towards us, the further along the vanishing point will slide. But if we swivel this third one so that it faces us directly, so we're looking straight onto it, in fact, these lines will be parallel and there will be no vanishing point. And if we were to look down on this, we would be seeing a plan that looked something a bit like this. Now, if a building swings out at 90 degrees, of course, we're obviously going to recognize that. The problem is when a building swings out very slightly. So if we look at our lines here, this is pretty much looking straight at the scene. This is directly in front of me when I took this photo. And what I can see is that this building actually swings out at a slight angle. If this represents this building, which of course is angled at a corner, the fact is it doesn't go straight up in this way. It actually tilts out slightly. And this tilt means that it is no longer parallel with the buildings across the road. This end is closer than this end. And that's enough of a difference to stop this working the way it does so neatly in our perspective videos. So that's a problem. When I go to draw this, there's another problem which may occur depending how good I am at observing or not so good at observing the actual detail that I'm drawing. Because when I've watched videos such as this, we do get a sense of everything lining up. The tops of the roofs, all the windows and doors. Now, in life, that doesn't always happen for different reasons. Sometimes it's the architecture. The buildings simply are designed differently, and some have taller windows and some have narrower windows, shorter windows, wider windows. And that can explain some variation. But if we look at this row of windows, if we look at this row of buildings, we don't see a nice straight line. It comes along and down and up and down and up. It's saggy like some mattresses I've slept on in my time. Why isn't it even approximately looking like this? And there's another reason for that we're usually not warned about in our perspective videos. But let's see what happens when we do this. So what's happened here? Well, in this streetscape, this building has been lifted. This building's been lifted, but it's also been turned out slightly. And this building has been dropped back down and is back in the same alignment now as the first one was. It's just a little bit further forward. Now, what this means in practice is that the ground here is very uneven. So if we have a roadway in front of these buildings, it won't just need to come up over the hill that lifts these two centre buildings, but it will need to actually shift a bit this way to come around this building now, which pushes out, taking up some of the space that the street would have been in had it stayed in a straight line. And so this is what we see at work, because what we see and how we see it in these perspective videos is only true if the two sides of our street face each other in two straight lines that are exactly parallel and the ground is all flat. Once we start to shift the ground level, that starts to impact our buildings. And of course, added to the complexity of the moving ground and directions of the buildings, we have the fact that they're not all identical boxes the same size and height with windows and doors all the same. In fact, they're very different buildings of different stories with different constructions and different roofs. Let's just have a closer look at this section. And before we start to look at it, I'm just going to lock my eye level in place with a bit of tape. The one thing about eye level, again, that's not always made clear, is that eye level is always the same for the entire scene, regardless of which way the buildings are facing or what height the ground is. Eye level will always remain the same, and all the perspective angles will always meet on eye level. It's just that they won't all meet at the same vanishing point. There can be there can be dozens of different vanishing points for the one scene. The other way we can work out eye level is if eye level is the point where the lines all meet, and if we think of the lines as being some angle down and some angle up, eye level is the point where the lines actually are in a straight line. So that's the other way, and sometimes it's a more accurate way, particularly when you get a situation like this where, goodness, the windows are all really quite different in terms of how high they go. So where do the lines change direction? And again, this also assumes that the lines are horizontal. And if they're not, if the buildings are a little out of line, which can happen easily in these older places, then that also means our buildings won't line up as neatly with the perspective videos as maybe we would like. But these lines are moving. This line goes down, this line goes up, these lines go down, down. I think that eye level is going to be here. The tops of these windows don't seem to line up properly, but if we look carefully at the tops, you can see that this window has dropped out of alignment and is actually lower than it really should be if it were in a straight line. So I'm going to put a bit of tape in place just to hold that there. So let's see where our vanishing points line up for this side of the street. I've moved my eye level to the left because I've realized this is where I'm going to need it to join up my angles. So for this building, the vanishing point is going to be there. For this building up here, looking to see where the perspective lines meet, we can see that the vanishing point is just off camera. For this building here, the vanishing point is just about a centimetre further to the left than this one was. And for this one, it's going to be about here. And when we get to this final building, it's actually got the closest vanishing point of all. So why is this? Why is the vanishing point for every one of these buildings so different? And the answer is one that's really not so apparent, because this looks like it's a straight street, pretty much. But in fact it's not. There are two things happening here. One is that there is a dip in the street. The street goes down and comes up again. And if we're not looking out for it, it's not super obvious. But while this street looks straight, it's clearly not. Now we said eye level was approximately here. Now if the ground's flat, we can take a point anywhere on this wall close to us and it will be in a straight line to the vanishing point. So if we look at the vanishing point for this building, it's going to be about there. And if we take a straight line to there from our point, what we see is that we don't have a straight line along the base of all our buildings. The line goes down, and for some of the buildings, their baseline is lower than here, and for others, their baseline is actually going to be higher. And what's happening is that as well as the ground going down and then up at the far end, these buildings also start to curve around. If we look up here, we can see that on the right side of the road, there are actually two car lanes in effect, but up here there's only one. We can also see, in fact, that there is a very slight curve here. That this, in fact, is not parallel to this. Even if this were straight, this wouldn't be parallel. There is a slight curvature in the street here. And this point here probably represents where the street comes out most, and then it starts to curve back again as the street opens up and becomes wider. And this dip and rise again in the road and this curving in the street all means that this nice little simple diagram that we think applies doesn't apply, except in a very general sense, which is not good enough when we have to actually put lines on the paper. And that's why we have multiple vanishing points on our eye level for all of these buildings, because they do not line up in 180 degrees with each other. They tilt, although in this case they tilt away from us, not towards us. So we actually see these further buildings more foreshortened than we would if they were in a straight line. So how does this help us if we're drawing this scene? What use is the video? Well, the information in the video is still useful because it tells me generally what's happening, particularly if the video talks about foreshortening. But what I need to do when I look at any scene is to observe carefully enough the detail to understand what's happening with the street. Is the ground level actually 180 degrees straight? Is there a straight line from the ground on one building to the ground on the other? And you can see just how much here the answer is no. There is a much bigger dip here than we would expect just looking at this. because with the sunlight, there's no real shadow being produced by the dip. But it's not just that the ground level is sinking down in this part where the road dips down and then rising again further along. But further along, the ground level is also curving away from us slightly as the street opens up. But every time a building, or perhaps one or two buildings in a row, changes the angle of their alignment with the street, then a new vanishing point will be formed on our eye level, which we've seen happens for all these buildings. What this sort tells me when I draw this scene, besides that I need to carefully work out is the ground flat, is I need to not presume what I haven't seen. I need to not presume that the ground is flat, that the buildings are all at 180 degrees. Some of them can tilt forward just a little bit, but enough that these rules don't apply in the same way, that actually a second vanishing point is created for the left side of the street, or at the very least for this one building. If I were drawing this scene, I would start by drawing this section because it's relatively simple. I would draw this to here, and then I would get my alignment of probably this line here from this side. I would be seeing that this corner is just a bit above the bottom of this window, and that this corner is just a little bit above the corner of here. And then once I got this in place, I'd get these angles by referencing off my reference onto my paper. And once I had this, I would then come down the street, drawing each building as it goes, continuing to reference from both here and from here as, if you like, a check. And I'd pay particular attention to keeping these lines very close together as I move further along, and I would probably switch from a 0.3 or maybe even 5 millimeter pen up here to a 3 or a 2 and maybe even a 1, so that I can draw these lines very finely and have them really look like they're a long way away and still capture some of the detail without the lines merging into an inky blob. And because these videos don't tell you all of this, in their 6-minute presentations don't prepare you for this. We're looking for a simplicity here which just doesn't exist. The principles are all correct, but we can't apply them as easily as we think unless we have boxes that line up in this way on completely flat ground. If you found this helpful and you'd like a little more information about these different scenarios, I have separate videos on what happens with perspective when the ground goes up, with what happens with perspective when the ground goes down, and what happens with perspective on curved streets. And I think watching each of those videos would go a long way to giving a very thorough demonstration of what the videos don't teach you and don't even prepare you for knowing what you'll need to learn later on. This building up here is also at a separate angle to all of these buildings, and so it will have its own vanishing point. But its vanishing point will also be on the same eye level, because the eye level is the same for every single item, building, people, cars, trees, in the one scene. But if you'd like a little more detail, then please check out those 3 videos of mine that I think complete the picture for understanding more comprehensively exactly what we can expect and how we can draw buildings when the ground goes up and down and the streets go round corners. I hope this has turned on a light switch for you if you've struggled to understand why you can't apply perspective videos. I cannot understand why so many of them are as simplistic as they are, because they really don't prepare us for drawing, and therefore they make perspective seem a lot more difficult than it really is. G'day, I'm Travers. Hey, whatever you're drawing and however you're drawing it, make sure you have fun. I'll see you next time. Bye.